We've been getting a lot of good questions about Thevenin and Norton, including one of the first times that I receive a video that's been posted on YouTube by someone else. I think the account name is like Electric Circuits maybe, that is solved wrong. So if you have been following a solution to this circuit here on the Thevenin equivalent online, there is a chance it's wrong. So I wanted to use parts of his solution, but point out where it's wrong. Most of it is actually correct, but I want to say that every time there is a question about Thevenin equivalent, there are really two parallel circuits. One circuit does not depend on the other that I am expecting you to solve. One is for VTH and one is for RTH. And at the end, we're going to draw a circuit like this. Resistors can be resistor on the top or bottom, and this is going to be the resistance and the voltage. And these two nodes here, A and B, will be these two, A and B, or B and A. So for Thevenin, we're trying to find an equivalent circuit that is exactly the same as this. And because this is a dependent source, we cannot just turn it off to find the resistance, as we would do with simpler circuits. So for the Thevenin resistance, we turn independence off and add test source. And he does that too. And then by the end, find, if the test source is voltage, find the current. And then the Thevenin resistance will be voltage divided by current. But it's going to be this VT and this IO, for example, VT divided by IO. If you add a current, a test current, then it's going to be, and find the voltage as an output, then it's going to be VO over IT. The VTH, though, is this voltage here. So this circuit does not show in the load, so we're not going to do anything about it. If it had said the 10 ohms is the load, we would take it out. But in this case, it's not. So all that it takes is what you already learned how to find this voltage here across the 10 ohms, but everything else is the same. Actually, everything is the same. So this is Vx, and this here is 0.5 Vx. And it turns out he does do this. He finds this voltage by using nodal voltage. So if you consider this 0, this node here is 5 volts. And then you need to write a KCL for node A and a KCL for node B. And by doing this, you find the V over the 10 ohms is 50 over 3 volts, which is which is 120 divided by 3 is like almost 17 volts. So this here is the VOC, and it's also the V Thevenin, and we're not going to use this for anything else. We're not going to use this on this side. So the V Thevenin, I am done with this. I'm going to say it's 17 volts. And I'm going to go over to the Thevenin resistance, and this is where we're going to find the current that goes through a circuit that's like this. I'm going to short the circuit, this power supply, because it's voltage. So it's going to be 3 there, 6. Two, 10. And now is where we're going to put a power supply, and I'm just putting the 1 volt here because that's how the person did on the original YouTube video. And now I am interested in this I naught here. And if you use nodal or mesh, you can do 3 and 6. You're going to have a 2 ohm here because these two are in parallel, and you keep the Vx there. So you have 4 ohms, and then you have a current supply. So you do a 2 mesh analysis, or you assume nodal analysis, and this is pretty much done for nodal analysis because this is 1 volt. And you can do source transformation on this. So there's 3 or 4 ways of solving this, but I have the feeling he finds IO equals 110 amps, 1 over 10, which is 0.1 amps. And now the next step is the only one that he did not do correctly. The Thevenin resistance is going to be 1 volt divided by this current, 0.1. It's going to be 10 ohms. So this here is the answer to the Thevenin equivalent for this circuit. I'm hoping the math for this and this is correct, but assuming it is, then this is the answer. So V Thevenin does not jump over to here, and this I sub O is not the short circuit current. So if they had asked for the Norton equivalent, we would have shorted A to B, and this would have shorted out the 10 ohms, and we would have solved this independently. I hope this helps.